Okay, and hello to you and welcome to the final video on straight lines, where we look at modelling. The concept of modelling is a very important theme through the A-level course. You'll see it in pure mathematics and statistics and mechanics. So this is your introduction to it through straight lines. So what is a model? A mathematical model is an attempt to represent a real-life situation using mathematical concepts. Models are used all around us to simulate scenarios. Okay, it's often necessary to make assumptions to create the model. We don't really want to look at all the finer details to create a model. So let's just go through some basic concepts you might have seen at GCSE. So two quantities are in direct proportion when they increase at the same rate. The graph is a straight line through the origin. So if you got y proportional to x, then that implies that y equals kx for some real constant k. And this concept you must have seen before at GCSE. Okay, so let's have a look at this question here, and this is your first sort of step into modelling. On an old mercury thermometer, a temperature of 0 degrees reads as 32 degrees Fahrenheit. Similarly, a temperature of 20 degrees reads as 68 degrees Fahrenheit. The relationship between degrees Celsius and degrees Fahrenheit can be modelled as a straight line. If temperature is in degrees Celsius is x and temperature in degrees Fahrenheit is y, find the equation of the line in that form. So let's just try and imagine this as a graph. So they're telling us that degrees Celsius is x and degrees Fahrenheit is y. Okay, and in that respect, the data they've given us, they're coordinates. Yeah, so the temperature of 0 degrees Celsius is 32 degrees Fahrenheit. That's a coordinate 0, 32. Similarly, a degree 20 degrees Celsius reads as 68 degrees Fahrenheit. So if I go just along some distance, 20, then that will give me a point here. So 20, 68 degrees Fahrenheit. Okay, we can sort of make a straight line like that. We're not asked to draw the graph at all. Okay, but it's just making the concept clear that we're modelling a situation which can compare a Celsius temperature to a Fahrenheit temperature. Right, since we've got two coordinates and they're asking for the equation of a line, we can sort of think about the previous video where we looked at finding the equation of a line. We need three things. We need a gradient, we need an x value, and we need a y value. Now I can pick any of these two coordinates for x and y. I'm going to pick 0 and 32 just for the sake of argument, but I don't have my gradient. However, I can find that. So I'm just going to do a quick calculation to find my gradient. y2 minus y1 over x2 minus x1. Okay, so y2 is 68, y1 is 32, x2 is 20, x1 is 0. So when I do this, I get 36 over 20, and that can simplify down to divide both sides by 2, 18 over 10, go a bit further, you get to 9 over 5. So I want to try and get as far down as possible. Okay, so that's my gradient, 9 over 5. Okay, now let's try and find the equation of this line. We'll do this formula here. I've got all three things that I need. So y minus 32 equals 9 over 5 x minus 0. And they want it in this specific form, ax plus by plus c equals 0. So we can't leave it in this form, even though this would be acceptable if they didn't ask for that. So I'm going to multiply through by 5. So you've got 32 times 5. Which is 160. Okay. 5y minus 160 equals 9x. And they want it ax plus by plus c. So I'm going to take everything over there. 9x minus 5y plus 160 equals 0. And that is my final answer. So this is your first example of modelling with straight lines, and it's just making sure that you understand what you're dealing with in terms of linear variables, what's x, what's y, and how you can use the skills of straight lines in different situations. So there's some practice questions outlined here, and there's a stretch and challenge outlined there if you need to have a go at some harder questions. And that's the end of straight lines. Thank you.